Our world is increasingly about making decisions about decisions. Deciding alone is no longer enough. We need to reflect on and optimize the prerequisites, the environment, and the possible consequences of collaborative decisions involving both human and artificial intelligence. This is a higher-level leadership task that requires its very own competencies. We call this meta-leadership. Meta-leaders think and act differently. By adopting a really holistic approach, they link the efforts of different teams to their respective missions and goals. This is how they create valuable connections that feed into a common goal and lead to better performance and overall outcome. Meta leadership gives a new framework to the process and practice of leadership. First, it provides a comprehensive organizational framework for understanding and integrating the many facets of leadership. Second, it gives us a method to better design the interaction of different teams as well as people and technology. And third, it puts the focus on improving the team's functioning and performance.
So much for deriving a new concept that partly redefines leadership roles in the interaction between humans and AI. Now, let's get more specific. What exactly will the interaction between humans and machines look like? Can the various forms of interaction be systematized? And what does meta leadership mean in this context? We can distinguish between 4 variants of human-machine cooperation, and we would like to introduce you to each of them and explain what each variant entails for human leadership behavior.
Well, first of all, we have the human-in-the-loop approach. In this model, the human makes the decisions. The machine only offers support for decision-making or automates some parts of the decision-making process. This model is often referred to as intelligence augmentation, or IA. Here's a concrete example from logistics. Human-in-the-loop AI can help human decision-makers process tickets or routes more efficiently. For this human role, also known as a dispatcher, there are always many disruptive factors that can prevent a smooth service. For example, the need for a certain key or code that is unavailable at that precise moment, or a time window during which a pickup may or may not be possible, or temporary construction work on the route, and many more. A bot can help solve those kinds of problems. It sifts through all tickets and requests to identify anything that might affect a particular route and brings it to the attention of the allocators. This way, the bot proactively identifies any potential issues for the route as it is currently laid out, and it repeats this as stops are being added, moved, or removed throughout the day. The dispatchers can then use the bot to determine the best way to handle requests for logistic routes. While the human dispatcher monitors the system, the bot saves 20 to 25% of his working time by automating thousands of small decisions regarding various problems.
Let's look at the second model, the human-in-the-loop for exceptions model. In this model, most decisions are automated and the human only handles exceptions. For these, the system needs some input from the human before it can calculate the decision. The human also controls the logic to determine which exceptions get flagged for review. Take, for example, a cosmetic brand. This brand develops a machine learning algorithm to predict the sales increase for different types of promotions. The idea is to replace the existing optimization process performed by humans. AI prediction takes into account factors such as offer, marketing support, seasonality, and other factors to automate predictions. For many promotions, the prediction works well. But executives quickly lose confidence in the system when initial success is followed by some dramatic failures that result in significant losses. When data analytics review the predictions, they find that the algorithm appears to have difficulty predicting very specific types of promotions. Instead of abandoning the project altogether, they develop a new human-in-the-loop for exceptions approach and they modify the algorithm so that it learns to distrust its predictions for specific advertising actions. This way, the algorithm alerts the person overseeing the process to check the made prediction first. Let's take another look at the mental journey we have embarked on together throughout the individual lessons. The ability to make a choice, make a decision, is a fundamental requirement for us humans. Making informed decisions between various options is crucial to our existence. This is our DNA. In earlier times of human evolution, this process was controlled by instincts and hormones, fight or flight. Today, the complex interplay of intuition, experience, shared memories, and rational thought is what pushes us in one direction or another. As technology continues to advance, human invention is opening up possibilities in areas we once thought unimaginable. And so the tools that help us make decisions are becoming more sophisticated too. Neural networks and quantum computers are replacing calculating machines and mechanical clocks. Algorithms and digital data processing have replaced coding instructions that were once punched on punch cards, for example in the 1950s still. Machines have learned to predict the future by recognizing the patterns hidden in vast amounts of data. In the process, the boundaries between humans and machines are becoming increasingly blurred. As a result, many people face the challenge of navigating this new AI-driven reality. Our roles and responsibilities as leaders and employees, even as people, are changing because of how AI is delivering increasingly better results. And as AI becomes increasingly important in our strategic and operational decision-making processes, we ask ourselves, what becomes of the human element in the equation?